Welcome to Brain Vision.
Hi everyone, so what we have is a vertical piston cylinder that has an initial volume of 0.25 cubic meters, an initial pressure of 600 kilopascals, an initial temperature of 300 degrees Celsius. There's a valve that's open until 3/4 of the mass escapes, and the final volume is 0.05 cubic meters. What we're asked to find is the final temperature in the cylinder and the boundary work during this process. So what we're going to do first is look at our gas properties, and since we're dealing with air, we know the gas constant of air is R is equal to 0.287 kilojoules per kilogram Kelvin. We can solve for the initial mass just by using the ideal gas law. So we can say that M1 equals P V1 over R T1, and these are terms that we all know. So when we plug in for these values, we get an initial mass of 0.9121 kilograms. We know that the final mass is going to be equal to 1/4 of the initial mass, just because we know that 3/4 of the initial mass leaves the cylinder. So this will just be 1/4 times M1, and this is equal to 0.2280 kgs. We can again use ideal gas law to solve for the final temperature. We can just rearrange terms to solve for temperature 2, such that T2 is equal to P V2 over M2R, and this is going to be equal to 458.4 Kelvin. What we're going to do now is solve for the boundary work, and we see that the pressure actually remains constant during this process. So the boundary work is simply going to be calculated from saying that the boundary work is equal to P times delta V. This is equal to P times V1 minus V2. And plugging in for these quantities, we get a final work of equal to 120 kilojoules. And that's our final answer.